Hello, everyone, and welcome back. Today, we're going to be talking about the surface area of the sphere and the cone. In future, we'll talk about the volume of these two three-dimensional shapes as well, but for today, we're going to stick with the surface area. So what's the formula for the surface area of the sphere? It's 4 pi r squared, right? So instead of just regular pi r squared like we would have for, the area of the circle, this one is going to be 4 pi r squared. Okay, so let's answer these next couple questions. Here it says determine the surface area of the ball below. Well, it looks like the radius here is 3 centimeters. So the surface area is going to be equal to 4 pi 3 squared, which is equal to 4 times 9 times pi, which is going to be 36 times pi, which let's see, if we grab our calculator, we can figure out that 36 times pi is about 113.1 approximately centimeters squared, right? Because surface area is still an area, so our units will always be square units, right? Whether it's square feet or square centimeters or whatever it is. Okay. Now let's move on to example 2. So example 2, we have a diameter of 10 meters, right? So the radius is the diameter divided by 2, which is the same as 10 divided by 2, or 5 meters, right? Awesome. And then we're going to have our surface area is going to be 4 pi r squared, right? With r being 5, right? Since our diameter is 10, our radius is 5. So now we have, this is going to be 4 times 5 squared, which is going to be 100 pi, which, let's see, 100 times pi is going to be 314.2 approximately. It's really 1592, but we're just going to round that up to 2 meters squared, or square meters. And there we go. So luckily, surface area for sphere is a pretty simple one, right? It's really just pi r squared, and then we multiply it by 4. So in terms of finding the surface area of the sphere, it's not really much harder than finding the area of a circle. There's really only one variable we have to account for, which is the radius. The only trick is to make sure that if they tell us what the diameter is, don't use the diameter in place of the radius. Make sure you divide the diameter by 2 first to get the radius, and then you sub in. So that's the only mistake students tend to make with surface area. That or not knowing the formula are really the only two possible mistakes I really see people making with the surface area of a sphere specifically. Good. All right, let's now do the surface area of a cone. So the surface area of a cone is pi r squared, right, which is going to be the area of the base of our cone, plus pi r s, right, which is pi r times the slant height, s. Okay? So now we're going to calculate the surface area of the waffle cone below from an ice cream store. Okay? So here it says that we have 9 as our radius and 15 as our slant height. So surface area in this case will be pi times 9 squared plus pi r s. And now let's solve. This is going to be 81 pi plus, what's 9 times 15? I think maybe 105? No, 135. My apologies. 135 pi, which is going to be 216 pi as our, exact answer. And then to approximate that, it's going to be about 678.5 0.58 square centimeters for our overall surface area. So there we go. All right, let's move on to this next one. Here they've given us the radius and they've given us the height, but what we don't have is the slant height, okay? We don't have S. So a common mistake people make here is they think, oh, 8, they plug in 8 for S, but that is not correct. 8 is the height, 8 is not the slant height, okay? So keep that in mind, that sometimes we might have to find one or more of the variables in order to sub in. But luckily for us, this looks to me, and this is a right angled triangle. So we can use Pythagoras' theorem to solve for S, right? S is our slant height, and it's also our hypotenuse of the triangle. There's a whole lesson about Pythagoras' theorem for if that's something that you're needing to learn, or some of you may have learned it last year in grade 8 or grade 7, that sort of thing. But do make sure you're familiar with Pythagoras' theorem for this unit, as it does come back up again in this unit as well. So basically, we know that a squared, which is going to be 6 squared in this case, plus b squared, which is 8 squared, is equal to c squared, which in this case is our slant height squared, so s, right? The squares of the two sides that aren't our hypotenuse, right? The two sides that are adjacent to that right angle, added up are equal to the square of our hypotenuse. So now let's figure it out. S squared would be 36 plus 64. So S squared is 100. And so that means that S is equal to 10, right? Because it must be a positive number. It can't be a negative number in this context. So therefore, our slant height is 10 meters. Okay, now that we found our slant height, let's find our surface area, which, as a reminder, is pi r squared plus pi rs, right? Yes, it is. So now let's plug those values in. Pi 6 squared plus pi 6 times 10, which is going to be 36 pi plus 60 pi, which is 96 pi, which is our exact answer. Now let's find our approximate answer by doing 96 times pi in our calculator. And that's going to give us 301.59 meters squared. And there we go. Very good. Okay, well, I think that is it for today, because the next lesson, it has to do with volume. So we will see everyone next day to talk about volume, but I wanted to get a couple different surface area, a couple different shapes in for our surface area first. But long story short, as long as you make sure that you follow the correct formula and that you follow you plug in the variables correctly, then you should be good. Well, good work today, everyone, and we will see you next day. Bye, everyone.